In October of 2025, a non-peer-reviewed conference paper was published by the Society of Petroleum Engineers. The principal author is Carlos Mata of Scientific Lightning Solutions. Despite the accolades, the published work contains safety-critical misinformation and demonstrates confusion about the effect of grounding, the effect of catenary wires, as well as including questionable comments about NASA's experience with protecting storage tanks. For example, consider the following statements. Nearby strikes also pose serious risks. Without shielding or bonded down conductors, the resulting electric field rise can lead to streamer formation from ungrounded metal surfaces. Streamer formation due to electric field rise is not limited to ungrounded metal surfaces or objects, but also includes grounded metal objects. Grounding does not prevent streamer formation due to an external electric field. How would lightning rods even work if grounding prevented them from forming streamers? The electric field produced by the descending lightning leader causes grounded lightning rods to launch upward leaders. So every time a lightning protection system works as intended, that's proof that grounding does not prevent streamer formation. Similarly, the electric field rise due to the cloud charge field or nearby strikes can also lead to streamer formation from grounded conducting objects. Grounding and bonding can only prevent streamer formation or sparking in between conducting objects. It does not prevent streamer formation from a single conducting object into the surrounding air. More formal evidence that grounding does not prevent streamer formation due to nearby strikes can be found in the papers of C.B. Moore. Consider a lone metallic fitting in a fiberglass tank. In one case, the fitting is grounded, and in the other, it's not grounded, or it's floating. When exposed to an external electric field, the floating object will act as a dipole, which generally limits the electric field enhancement around the fitting, thereby limiting the length and energy of any induced discharges. Under the same conditions, the grounded fitting is not subject to this limitation, and can therefore produce longer, more energetic discharges that may be more likely to ignite flammable vapors. So, although grounding is recommended for other reasons like static charge mitigation, when it comes to the hazard posed by external electric fields, such as nearby strikes, grounding metallic objects on fiberglass tanks without EM shielding actually makes things marginally worse. Here's another statement that further demonstrates confusion about the effect of grounding. This configuration also allows maximum exposure to lightning electromagnetic pulse and ground potential rise, both of which can damage internal equipment or generate arcing across loosely bonded or floating components. Again, the threat posed by lightning electromagnetic pulse or nearby strikes is not limited to loosely bonded or floating metal surfaces, but also includes grounded metal surfaces or objects. Also, a floating object would not be exposed to ground potential rise. In order to feel the ground's potential rise, an object must actually be connected to the ground or grounded. So in the example of the two metallic fittings in fiberglass tanks, the floating one would not be exposed to ground potential rise, whereas the grounded one would be. This kind of misinformation about the effects of grounding can be devastating to oil and gas facilities, all while giving a false sense of security. Upon his request, we provided Carlos with a list of problematic statements from his paper with references and proposed corrections, which you can download yourself from the description of the video below. As of the making of this video, we've received no reply.